Okay. Next is question number 24. Correct? ये आपका ही है ना? Yes. Define moment of force about pivot. क्या होता है? Force multiplied by perpendicular distance from the pivot. आवाज आ रही है आपको? ठीक है। सो जो आपने कहा था, इसमें हम लिखते हैं the product of force and perpendicular distance from the pivot. The product the product of force and perpendicular distance and perpendicular distance from from pivot. The product of force and perpendicular distance from pivot is called moment of force. Next पढ़ें बच्चे क्या है? G. SI based unit. We know the formula moment equals F into D. F equals kg meter per second square and D is meter. So the answer is kg meter square per second square. Okay. ये लो जी. Okay, next is the uniform rigid rod of length. Length is given, is shown in figure 1.1. Next is the rod has a weight. Weight is given, length is given, the density. Okay, the rod has a weight of 5.2 and is made up of wood of density this. Calculate the cross-sectional area in millimeter square of the rod. You have to find out the cross-sectional area of the rod in millimeter square. हाँ, okay. जी कैसे find करें? How many things we have? Length, weight, density. So we have to use W equals M into G. So M equals W, oh, M in equals W over G. Now W is the weight. Weight is what? 5.2, G is 9.8. 5.2 over 9.81. So the answer is 0.53. And we know that density equals mass over volume. So volume equals mass over density. Mass is, where mass is 0.53 over density. Density is 790. So volume equals, check it. 6.7 multiplied by 10 raised to power minus 4. 1, 2, 3, 4. Yes. Okay, next is, we know that volume equals area into the height. Height in this question is the length of the rod. So area equals volume into height. Height is basically length here. So area is no, sorry, volume is 6.7 into 10 raised to power minus 4 over area, length कितनी 2.4. Height is 2. Height in this question is the length, which is 2.4. Check करें क्या आता है आंसर. Important है ये. 2.8 multiplied by 10 raised to power minus 2.8. ऐसा ही है. 10 power minus 4. But we have to, no, we have to convert them into millimeter square. And if you remember, millimeter square equals to, this one is in meter square. Millimeter square is, milli is 10 power minus 3 and its square is minus 6 meter square. So we should have to write in this way 280 and this would be 10 power minus 6 हो जाएगा. Initially it is 2.8 na, 2.8 10 power minus 4. So 280 will be equals to 10 power minus 6. ठीक है. So this is equals to meter square and you know that 10 power minus 6 is millimeter square. So this will be, yes, 280 millimeter square is 10 power minus 6 meter square. Any confusion? Okay. Answer check करें इसका. 24 part. हाँ 2. हाँ अच्छा वो ऐसे लिखा होगा. ऐसे लिख दिया ना. 2.8 10 पावर 2 लिखा है ना. वो सही है. ये भी ठीक है. नेक्स्ट इज अ फिशिंग रॉड. उन्होंने टू सिग्निफिकेंट, अच्छा उन्होंने टू सिग्निफिकेंट में लिखा है. ठीक है. सो दिस इज 2.8 10 पावर 2 millimeter square in two significant figures. A fishing rod AB made from the rod in B is shown in figure 1.2. So where is the fishing? AB is the fishing rod. Okay. There is a string, there is a stick और ऐसे आपने उसको hang किया हुआ. Next is the end A of the rod rests on the ground and string is attached to the other end B. A sport stick exerts a force perpendicular to the rod at point C. The weight of the rod acts at point D. The weight is acting here. Okay, this one is the weight. Weight is given. The angle is given. And the tension T in the string is in the direction perpendicular to the rod. The rod is in equilibrium and inclined at an angle is given to the vertical. The forces and the distances along the rod of points A, B, C, D as shown in figure. Okay, सारी चीजें figure में already given है. ठीक है. Show that the component of weight that is perpendicular to the rod is 4.3. So the component of weight which is perpendicular to the rod is कौन सा बनेगा. यहाँ पे एक कंपोनेंट बचे ये बन जाएगा and the second component is this one. So the component of weight which is perpendicular to the rod is mg sin theta है ना. So तो हम लिखेंगे the component of weight perpendicular to the rod is 5.2 sine 56. So 5.2 sine 56 is 4.3. So 4.3 Newton is the answer. By taking moment about and A of the rod, calculate the tension T. You have to find the tension T, and for this we have to use clockwise moment, clockwise moment equals to anti-clockwise moment. Clockwise moment equals to the anti-clockwise moment. Now, clockwise moment is due to clockwise moment is due to किसकी वजह से लग रहा है? The A is acting as a pivot now. So clockwise किसकी वजह से होगी? हाँ, this stick creates a clockwise moment. ठीक है? And the anti-clockwise moment is due to the perpendicular component of the weight. This will create an anti-clockwise moment, and this string also creates an anti-clockwise moment. Any confusion? अच्छा जी, अब हम इसमें now we know we have two anti-clockwise and we have one clockwise. So clockwise moment is 4.6. इसको ऐड करें जरा डिस्टेंस को 0.6 और 1.2 1 this is 1.80. So 4.6 into 1.80, this is the clockwise moment, and we have two anti-clockwise moment. One is एक तो बचे ये 4.3 है perpendicular 4.3 due to weight and its distance is 1.20 plus the other one is tension T and its distance is इनको ऐड करें 0.6 0.6 1.2. So T equals into 2.4. Now अब इसमें से टेंशन को आप सब्जेक्ट बना लें और आंसर बता दें. जी हाँ, so tension is 1.3 मीटर. ये तो सिंपल था क्वेश्चन. Next is state what is meant by the center of gravity of a body. Center of gravity is a point, the point where all the weight of the body appears to act. The point where all the weight of the body appears to act. ठीक है? Next is a uniform wooden post AB of weight is given, stands in equilibrium on a hard ground as shown in figure 2.1. Next is this is a horizontal post. There is a string. We have two strings here. The end A of the vertical post is supported by the ground. A horizontal wire with a tension T is attached to the end B of the post. Another wire attached to the post at point C is at an angle 60 degree. 60 degrees is the angle. Angle is 60 degree to the horizontal and has a tension of 38 Newton. So The distances along the post of point A, B, and C are shown in figure 2.1. Calculate the horizontal component of the force exerted on the post by the wires connected to point C. जी बच्चे, you have to find the horizontal component of the force. Horizontal तो ये होगा ना? Horizontal component of the force exerted on the post by the wire connected to point C. क्या क्या? हाँ, 38 cos 60, very good. 38 cos of 60 आ सकता है. So the answer is 19 Newton. By considering the moment about and A, determine the tension T. Tension आपने find करनी है. The distance क्या लेंगे? What should be the distance from point A? 0.9. Okay. Next is anti-clockwise moment is due to the tension multiply by, and its distance is 0.9, 0.3. It's 1.1, 1.2. Sorry, 1.2. तो सब डिवाइड कर दो. Hello. Hello. जी, वालेकुम सलाम. अब आवाज आ रही है? Okay. Okay, next आ जाते हैं इसी पे. कहाँ से skip हुआ था? 14.25, 14 Newton. Next is calculate the vertical component of the force exerted on the post at A. Vertical component के लिए हम क्या लेंगे? Vertical component sin देंगे ना? So 38 sin 60. So 38 sin 60. 38, 6.32.9. Next is रुकिए जरा, नहीं, there are two A पे है ना, so calculate the vertical component of the force exerted on the post. So the vertical component is, we already have a weight, so weight is acting, so this is equals to 45 plus 32.9. 45 plus 32.9. अब चेक करो, 77 point, so this is 78, लिख दो 78. उन्होंने कहा था A पे, so on A there are two perpendicular component of the forces, one is 45 and the other one is 38 sine 60. ठीक है ना, 30 ऐसे में शो कर देता हूँ, one is 45, the other one is sine 60. These two are perpendicular on A. For example, this is A, so two forces are acting on A. Next is state the principle of moment. Principle of moment is, in equilibrium, the sum of clockwise moment in equilibrium, the sum of clockwise moment is equal to the sum of anti-clockwise moment sum of clockwise moment equals to the sum of anti-clockwise moment about pivot, वो अच्छा वो होता है conservation of momentum in a closed system, then a momentum will remain conserved. Okay, next is, in a bicycle show, two wheels hang from a horizontal uniform rod AC as shown in figure 3.1. Okay, यहाँ पे we have a wall, we have two wheels, and we have a rod. Okay, there is a ceiling, there is a cord, the distances are given from point A. It means A is a pivot point, so you have to use clockwise and anti-clockwise. ये पढ़े जरा. So by taking moment about and A, show that the weight of each wheel is 14 Newton. बस यहाँ पे भी हम लगाएंगे clockwise equals anti-clockwise moment. Now we have to check how many clockwise moments we have. A is a pivot point, so this one is clockwise. This is also clockwise. This will be also clockwise. So three clockwise moments and one anti-clockwise moment. So simple है ये तो. And distances are given. अब मुझे जल्दी जल्दी बताते जाएं. सबसे पहले का force and distance कितना है? W multiplied by, it's not 45, it's 0.45 plus the second one is uh, the B is the weight of the 90. What's the distance from the pivot? 1.4, 1.4 plus 0.5. You have to add both of them. No, oh sorry, you are right. Okay, ऐसे करते हैं ना. What is the total length of the pivot rod? And you have to divide them by 2. ठीक है जी. So यहाँ पे हम लिखते हैं 19 into 1.3. Did you get it? How we calculate the midpoint? Uh, you have to add them and then divided by 2. Next is 1.85 and weight is unknown. Yes. And on the anti-clockwise, you have 22 into 2.6 is the total length. Yes. It's very simple. आगे आपका काम है. 14.13 आंसर चेक कर लें इसका. वेट अच्छा ये प्रूव करना है. 14.1, so this is 14 Newton. Next is determine the magnitude and the direction of the force acting on the rod at end A. A पे आपने देखना. Where is the A? What is the magnitude and direction of the forces acting on the rod at end A? Okay, this is the end A. How many forces are acting downward? 3. And how many forces are acting upward? Just 1. है ना? तो हम करते हैं upward forces equals downward forces. Upward forces equal downward forces. So there is only one force in upward direction, which is 22. And there are 3 forces. The first one is the weight. Weight is 14.1 plus 19. There is a second wheel, 14.1 again. Now this would be, just आप subtract कर दें. Subtract करके देखें क्या आता है आंसर. 14.1 plus 19 plus 14.1 minus 22. आंसर प्लस में है कि माइनस में है? 25.2. 25.2 न्यूटन. अब डायरेक्शन क्या होगी जी? What will be the direction? Goes down. Why? No, it's not a. वो तो हम उसको अगर दूसरी साइड पे ले जाते तो वो माइनस हो जाती. There are three clockwise and one anti-clockwise moment, है ना? Anti-clockwise is less than. अच्छा हम ऐड करते हैं, ऐड करके देखें 14 + 14 + 9। इसका आंसर देखें, इट्स अपवर्ड। इट शुड बी अपवर्ड। एनी रीजन यहाँ पे मेंशन है? एनी वैसे रीजन भी तो होनी चाहिए ना। हाँ वही मैं सोच रहा था, ये डाउनलोड क्यों नहीं है? ओके, अगर हम करते हैं क्वेश्चन देखते हैं, डिटरमिन द मैग्नीट्यूड एंड द डायरेक्शन ऑफ फोर्स acting on the rod at end A. अगर हम एंटी क्लॉकवाइज मोमेंट देखें, क्या आंसर आया था? एंटी क्लॉकवाइज मोमेंट इज 22 इंटू, क्या था? 22, this one, 22 Newton into the distance from A, 0.45, 1.4, 0.2.6, ऐड करें तो क्या बनता है? 50 समथिंग, 57 समथिंग था ना? 57.2 is the clockwise moment. And एंटी क्लॉकवाइज मोमेंट आप चेक करते हैं, सो 0.45 मल्टीप्लाई बाय 14.1 प्लस, फिर हमने किया था 1.85 इंटू 14.1 प्लस 24.7, इन सबको ऐड करें, दिस वन इज क्लॉकवाइज। नाउ वी नो द वैल्यू ऑफ W। मैं चेक कर रहा हूँ कौन सी वैल्यू ज्यादा है। ओ 57.13, ऑलमोस्ट इक्वल ईयर। सो वो एग्जैक्ट, अच्छा ये एग्जैक्ट 2.6 था, चेक कर ले। 0.45, 1.4, 0.76, आई थिंक यस 0.75। तो अगर हम एग्जैक्टली देखें तो एंटी क्लॉकवाइज मोमेंट is greater than the clockwise moment, so the net force in upward direction, ठीक है, vertically, हाँ, so vertically upward, upward, because the anti-clockwise moment is greater than the clockwise moment in my case। आप भी देख रहा कि इसका कोई any other reason, solid reason। okay, next पढ़े। or obey Hooke's law. Hooke's law is F is equals to K X. ठीक है, या E लिख दें या X लिख दें. So it means कि there is a direct relation between F and X. तो इसमें हम लिखते हैं कि initially extension is zero when the force is zero. Okay? Initially when force is zero, the extension is also zero. Second point is the graph is a straight line. The graph is a straight line means Hooke's law means the core obeys Hooke's law. The core obeys Hooke's law. Next is calculate the spring constant K of the core. Spring constant find करो. तो spring constant क्या होता है? F is equals to Kx. So K equals F over X. So we have to take the gradient of the graph. So कोई भी दो पॉइंट ले लेते हैं. Y2 is 60. ठीक है. 60 minus 0. 1 minus 0.5 ये ले लेते हैं. 60 minus 0, 1 minus 0.25. तो करो. 80. So 80 Newton per meter. Next, on figure 3.2, shade the area that represents the work done to exert the cord. When the tension is increased from 0 to 40. 0 to 40. When the tension is increased from 0 to 40. So here we have a 0. Here we have a 40. Here is a graph. This one is the area under the graph. ठीक है? Any confusion? हाँ, 0 to 40 उन्होंने कहा था ना कि एरिया अंडर द ग्राफ बता दें. So from 0 to 40 you have yes. हाँ, अब जिसको पता होगा कि एरिया अंडर द ग्राफ क्या लेना. हाँ जी, इसलिए आपने आंसर दिया. काफी है. Okay, the office